every type of meteor shower. Space is complicated. We make it simple. A shooting star isn't a star. It's not even close. It's a piece of debris, usually smaller than a grain of sand, hitting Earth's atmosphere at tens of kilometers per second and burning up in a streak of light that lasts less than a second. A meteor shower happens when Earth plows through a dense trail of that debris all at once, and every major shower on the calendar comes from a different source at a different speed, leaving a different kind of trail. We're going in order through the year's biggest displays, then we'll sort them a second way by what they're actually made of, because not everything burning up in the night sky came from a comet. The Quadrantids, we begin with the one most people have never heard of, despite it being one of the most intense showers of the entire year. Peaking in early January, the Quadrantids can produce over 100 meteors an hour at their best, rivaling or exceeding almost every other shower on this list, and yet it remains obscure for a brutally simple reason. Its peak lasts only about 6 hours, compared to the day or two of strong activity most other showers offer. Miss that narrow window, whether to weather, timing, or simply being asleep, and the show is functionally over for the year. Here's the thing that makes the shower genuinely strange. For over 2 centuries, nobody could identify its source. Every other major shower could be traced to a known comet, but the Quadrantids' parent body remained a mystery until 2003, when astronomers linked it to an object called 2003 Eon. And 2003 Eon isn't behaving like a normal comet at all. It shows almost none of the usual signs of cometary activity, like a glowing coma or a visible tail. And some researchers now classify it as a rock comet, or possibly the shattered remnant of a comet that broke apart centuries ago, one that Chinese astronomers may have recorded observing in the year 1490. If that link holds, you're watching the scattered wreckage of something that stopped being a single object over 500 years ago, still raining down in the same narrow week every January. The Lyrids. Here's the twist. This is one of the oldest meteor showers documented by humanity, with recorded observations stretching back over 2,500 years to ancient Chinese astronomers, making it one of the longest continuously observed astronomical events in recorded history. Peaking in late April, the Lyrids are a moderate shower most years, producing around 15 to 20 meteors per hour, respectable but not spectacular. Here's the fact that changes everything about how you should think of this shower. It has a documented habit of occasionally, unpredictably exploding into an outburst. In 1982, observers recorded roughly 90 meteors per hour during a brief surge, and in 1803, one account described the sky as being in a perfect blaze, with witnesses comparing the display to a light snowfall of fire. Nobody can reliably predict when the next outburst will happen. The source is Comet Thatcher, a long period comet that only swings through the inner solar system once every 415 years, meaning nobody alive today, and likely nobody in several future generations, will ever see the parent comet itself, only the debris trail it left scattered along its orbit centuries or millennia ago. You are watching the ghost of a comet's last visit, deposited generations before you were born, and the comet itself won't return until long after you're gone. The Eta Aquariids. Here's the reframe. This shower's debris trail comes from the single most famous comet in human history, Halley's Comet, and yet almost nobody associates the two. Halley's Comet, visible from Earth roughly once every 76 years, leaves behind a trail of debris so vast that Earth actually crosses it twice a year, producing two separate meteor showers from the exact same parent comet, the Eta Aquariids in early May and the Orionids in late October. Peaking in early May, the Eta Aquariids are best seen from the southern hemisphere, where rates can reach 50 meteors per hour, while northern hemisphere observers typically see a much thinner show, often under 10 per hour, because of the shallow angle at which the shower's radiant point rises above the horizon there. Here's the fact that should genuinely bother you. These meteors are notably fast, striking the atmosphere at about 66 kilometers per second, fast enough to frequently leave glowing trains, persistent streaks of ionized air that can linger visibly for several seconds after the meteor itself has already vanished. Halley's comet last passed through the inner solar system in 986 and won't return until 2061. Every meteor in this shower, every single year in between, is debris shed from a comet that most people watching won't personally see again in their lifetime. The Perseids. Here's the pivot. If you've only ever intentionally watched one meteor shower, it was probably this one. Peaking in mid-August, when northern hemisphere nights are warm and comfortable, the Perseids are widely considered the most popular shower in the sky, producing 60 to 100 meteors per hour at their peak, with a reputation for particularly bright fireballs. Meteors dramatically brighter than the background stars, sometimes bright enough to cast a brief shadow. The source is Comet Swift-Tuttle, a genuinely enormous object, roughly 26 kilometers across, more than twice the estimated size of the object, believed to have caused the extinction event that killed the dinosaurs. Here's the fact that should unsettle you a little. Swift-Tuttle's orbit brings it back through the inner solar system roughly every 133 years, and some long-term orbital calculations have, at various points, flagged a theoretical, though currently considered extremely unlikely, chance of a close approach to Earth on a future pass centuries from now. Refined calculations have repeatedly pushed that risk down toward negligible as more precise orbital data comes in, but the fact that it was ever on the list at all makes the Perseids a strange case. The same comet responsible for one of the most beloved casual backyard astronomical experiences of the year is also one of the larger nearby objects that orbital dynamicists keep a long-term eye on. The Orionids. Here's the twist. This is Halley's comet's second appearance on this list, and its October debris crosses Earth's path at a steeper, faster angle than its May counterpart, producing similarly fast meteors around 66 kilometers per second, but from a different direction in the sky entirely, appearing to radiate from the constellation Orion rather than Aquarius. Peaking in late October, typical rates run around 15 to 20 meteors per hour, though the shower has produced notable outbursts in specific years when Earth happened to pass through an especially dense filament of debris within the broader trail. Here's the fact that changes everything about how to think about Halley's two showers together. They are proof that a single comet's debris doesn't stay in one tidy trail. Over the roughly 2,000 years, astronomers estimate Halley's comet has been shedding material on its repeated passes. Gravitational tugs from Jupiter and other planets have spread, twisted, and thickened that debris into a broad enough band that Earth intersects it not once, but twice, on opposite sides of its own yearly orbit, meaning the same ancient comet is quietly responsible for two of the year's distinct meteor showers, 6 months apart without most skywatchers ever realizing the connection. The Leonids. Here's the fact that should genuinely bother you. Most years, the Leonids are an unremarkable shower, producing a modest 10 to 15 meteors an hour in mid-November. But roughly every 33 years, tied to the orbital period of its parent comet Tempel-Tuttle, the Leonids have produced meteor storms. Not showers, storms, with observed rates in the thousands of meteors per hour. The 1,833 storm was so intense that witnesses across North America described the sky as raining fire, with some historical accounts estimating rates as high as tens of thousands of meteors per hour, an event terrifying enough that it directly inspired serious scientific study into the actual origin of meteor showers for the first time. A more recent storm in 1966 briefly produced rates estimated at up to 40 meteors per second, a display so overwhelming that observers described it as looking like the sky itself was falling. Here's the pattern that makes this shower unlike anything else on this list. Comet Tempel-Tuttle deposits its densest debris in a relatively narrow, concentrated stream close to its own position, so the intensity of the Leonids in any given year depends heavily on how recently the comet itself passed through, meaning this shower cycles between forgettable and historically overwhelming on a schedule tied directly to its parent's 33-year orbit, and the next storm level event is a matter of ongoing prediction rather than guaranteed certainty. Before we get to the year's best shower, it's worth pausing on what's actually happening physically the instant any of these particles hit the atmosphere, because the visual you're seeing is almost entirely a misdirection. A meteor's glow isn't the particle itself burning the way a piece of wood burns in a fire. Most meteoroids are tiny, often no larger than a grain of sand or a small pebble, and they're traveling so fast, anywhere from about 11 to 72 kilometers per second, depending on the shower, that the real story is friction with the surrounding air. That speed compresses and superheats the air directly in front of the particle to temperatures exceeding several thousand degrees. And it's that superheated column of air, not the particle itself, that produces the bright glowing streak you actually see. The particle causing all of it is often completely vaporized within a fraction of a second, sometimes at an altitude of 80 to 100 kilometers, long before it ever gets remotely close to the ground. Here's the fact that should genuinely bother you. Despite the dramatic visual, the actual mass involved in a typical meteor shower is almost nothing. Earth intercepts an estimated 15,000 tons of meteoric material every year from all sources combined, which sounds enormous until you realize it's spread across the entire planet's surface and atmosphere over 365 days, an amount so thin and dispersed that it would take many millions of years for it to add even a single centimeter of extra material to Earth's surface, if all of it actually reached the ground, which the overwhelming majority never does at all. The Geminids. Here's the reframe that closes out the list. This is, by most measures, the single best meteor shower of the year, consistently producing over 150 meteors per hour at its mid-December peak, with meteors that tend to be bright, multicolored, and slower moving than most other showers, making them easier for casual observers to actually catch and enjoy. And here's the fact that upends everything you'd expect from every other entry on this list. The Geminids don't come from a comet at all. Their source, identified in 1983, is an object called 3200 Phaethon, classified not as a comet but as an asteroid, a rocky body that shouldn't, by conventional definitions, shed the kind of debris trail that produces a meteor shower at all. Phaethon's orbit brings it remarkably close to the sun, closer than Mercury, hot enough that researchers believe intense solar heating causes the rock to crack and fracture, shedding rocky debris through thermal fracturing rather than the ice sublimating off a traditional comet. Some astronomers now classify Phaethon as a rock comet, blurring the line between the two categories entirely. Here's the part that lingers. The Geminids are a relatively young shower in the historical record, first noticed in the 1830s and only reaching their current intensity within the last century or so, seemingly still strengthening year over year, meaning the single most reliable meteor shower currently visible from Earth might not have looked like much of anything to your ancestors, and its debris trail may still be actively thickening as Phaethon continues shedding material on each close pass by the sun. The Taurids. Here's the fact that should genuinely unsettle you more than anything else on this list. This is the least intense major shower by raw numbers, producing only about 5 to 10 meteors an hour across two overlapping branches in late October and early November, and it might be the most dangerous one anyone watches all year. The Taurids come from an enormous ancient debris trail associated with Comet Encke and a scattered swarm of larger fragments believed to be pieces of a much bigger object that broke apart thousands of years ago. Unlike most showers on this list, which are made almost entirely of dust and sand grain particles, the Taurid stream is known to contain a disproportionate number of larger chunks, meaning it produces noticeably more fireballs, meteors dramatically brighter than a typical shooting star, relative to its otherwise modest hourly rate. Every few years, Earth passes through an especially dense filament within the wider Taurid stream called a Taurid swarm, and fireball activity spikes noticeably above the baseline. Here's the part that lingers. Some astronomers have proposed, though it remains genuinely unconfirmed and actively debated, that the 1908 Tunguska event, an explosion over Siberia powerful enough to flatten roughly 80 million trees across 2,000 square kilometers, with no confirmed impact crater ever found, may have involved a fragment from this same ancient debris complex. Whether or not that specific link holds up, the broader torrid stream is considered one of the more plausible sources for city-scale airbursts, precisely because it's one of the only annual showers known to carry meaningfully large fragments rather than just fine dust. Most years, the torrids barely register as a footnote. Every so often, they're a reminder that some meteor showers are close cousins of exactly the kind of impact that ends a bad day very quickly. It's also worth understanding why every shower on this list gets named after a constellation it has, in most cases, absolutely nothing to do with. A meteor shower's name comes from its radiant, the single point in the sky from which its meteors all appear to originate, an optical illusion caused by perspective, the same reason parallel train tracks appear to converge toward a single point on the horizon. Every meteor in a given shower is actually traveling on a roughly parallel path relative to the others, all remnants of the same debris trail moving in the same general direction. But because they're all diving into the atmosphere from the same direction in space, they appear from the ground to fan outward from one shared point among the background stars. The Perseids radiate from the constellation Perseus, the Leonids from Leo, the Geminids from Gemini, but the constellation itself plays no physical role whatsoever in producing the meteors. It's simply the backdrop the radiant happens to sit in front of, a coincidence of the current alignment between Earth's orbital position and the ancient debris trail it's passing through. Here's the fact that changes how I should actually watch any of these events. The best meteors to see are often not the ones directly at the radiant, but the ones streaking across other parts of the sky entirely, farther from that point, because meteors close to the radiant appear foreshortened, short, and stubby, while ones farther away are seen more fully side on, tracing longer, more dramatic paths across the dark. Let's sort these 8 again, a different way, not by calendar date, but by what's actually falling. On the icy end, the Quadrantids, Lyrids, Eta Aquariids, Perseids, Orionids, and Leonids, all traceable to comets shedding ice and dust as solar heat vaporizes their surface on each pass. On the rocky end, alone, the Geminids, sourced from an object that behaves more like a fracturing asteroid than a melting comet, the outlier of the entire list. On the unpredictable end, the Leonids, capable of jumping from a minor curiosity to a historic storm, depending entirely on how recently its parent comet passed through. On the most ancient end, the Lyrids, documented by human observers for over 2,500 years, one of the oldest continuously recorded astronomical events humanity has ever kept track of. And on the doubled end, the Eta Aquariids and the Orionids, 2 entirely separate showers, 6 months apart, both secretly the work of the same comet, Halley's, the only object on this entire list responsible for more than one entry. Here's the last thing worth sitting with. Every meteor you've ever seen streak across the sky was debris shed from a comet or asteroid, sometimes centuries or millennia before you were born, drifting silently through space until Earth's orbit happened to carry you directly through its path. The comet itself might be gone, or 600 years from returning, or shattered into unrecognizable pieces, and none of that matters because the debris keeps looping around the sun on the exact same schedule regardless, faithfully arriving on the same week every single year, whether or not anyone bothers to look up. Not bad for stick figures on a rock.